Okay, welcome everyone. My name is Danielle Greshak. I'm a manager of solutions architecture based in Boston. I hope you all are very excited today to talk about containers. And hopefully everyone knows about the mini conference that's taking place at the Mirage on December 1st, and there will be some repeat sessions on December 2nd. I'll refer to some of those sessions, but just to give some level setting here, this particular session is just an introductory level session, and so we're just going to talk about some of the aspects of using Docker on AWS at scale. So the agenda for our session today, first we're going to talk about why containers. Hopefully all of you are here because you're hearing about containers, you think they're pretty exciting technology, and they are one of the hottest architecture patterns that we're hearing about, and lots of our customers have a great interest in them. But we'll talk about why you want to use them and what benefits they have in your applications. We'll talk about managing a cluster because you're never actually just going to run one or two containers, right? You're going to be doing this at scale. And there are lots of challenges with running a cluster at scale. So we'll talk about ECS, which is our cluster management system for running containers. And then we'll talk about the benefits that that service has. We'll talk about running services with ECS as well. And then I'll do just a quick demo, a little bit of hands-on with the ECS CLI, and show you how to set up a service on AWS. Okay, so why should you be using containers first and foremost? So, containers basically abstract the abstract the infrastructure and the operating system, which really just allow you to focus on your development workflow. So Docker as a technology really provides you with the ability to hook into Linux features and the Linux kernel that allow you to use such features as C groups, which allow you to limit resource utilization, and also namespaces, which really allow you to provide process isolation. So this way, certain processes can't see other processes, and also you can isolate parts of a shared file system. So, when I first started as a solutions architect with AWS 3 years ago, I had a lot of customers in my patch which were doing software as a service and platform as a service. And they were really on the container early adoption path pretty quickly. And it makes sense, right? Because if you're running software as a service or platform as a service, you want to make sure that you can really limit resource utilization on a multi-tenant system. And that's something that you can do at the operating system level. And you can start your applications very quickly. But that being said, POS and SaaS aren't the only reasons to use containers. So briefly, what containers are is they allow you to virtualize the operating system. I know most of you are probably familiar with virtual machines, which virtualize the underlying hardware and provide many guest operating systems. And what Docker does and why containers have really come into to be ubiquitous is because they really make virtualizing the operating system very easily. Docker has a great amount of tools and workflows that really allow you to build images and deployment workflows, and they allow people to interact with and manage these containers in a user-friendly way. And this has made containers much more broadly available. So Docker images make it really easy to define what is going to run in a container and what versions there are for the application, and you can put this into source code. And these concepts of containers really allow you to enable automation in your environment. So you can really define your app and you can build and share that image across your organization. Some of the advantages of containers, which is why a lot of people have a great deal of interest in them, is that they're portable. So the image is consistent and immutable. And really, no matter where you run it, it's going to be the same behavior. So I don't know how many of you work in software development and have built something on your machine and you run it and you say, okay, it works just fine on my laptop, on my workstation, but then you try to actually deploy this into production, and the server is just different. This was my life prior to coming to AWS, and that's the first reason why we chose to look into Docker containers when I was working in software development. And this is really a primary driver for people looking into Docker. The other thing is that containers are very flexible. So you can really create clean and reproducible environments very quickly. And they really make it easy to decompose an app into smaller chunks, such as microservices. Microservices we'll talk about in a minute, but this really streamlines both the deployment and the infrastructure management that you have to worry about. Containers are also very fast. When I was talking about building SaaS or PaaS, you can imagine that if I'm trying to create an instantiation of an application, well, I already have the operating system running, right? So I don't have to worry about starting up a whole new OS or a whole new stack for a customer. So this also has benefits for ops. So if you are just maintaining this single image, the IT can go and update that base image, and all you really have to worry about is building your code. Finally, containers are very efficient, and you can really allocate the exact memory, resources, CPU that you want. And this really makes running your underlying infrastructure a lot more efficient. So many of you may have heard this story before, but if not, I'll just tell it again. So 10 years ago, Amazon.com actually was one large monolithic application. And I'm sure many of you have a similar experience in your own environment. But in order to scale, Amazon realized that they needed to break this apart, because quite simply, they had certain services such as the order management service or the recommendation service or the user UI service. And each of these services had different needs from an infrastructure perspective. And they weren't able to scale the website as efficiently as they wanted. They also couldn't push out deployments as quickly as they wanted to. You can imagine when you have this one massive code base, you have to run all these tests, and you just can't deploy and produce new features as quickly as you want. So in order to scale, Amazon decomposed their application into individual microservices, which could be deployed separately. So this allowed it to scale each service separately. For example, let's say a recommendation engine that may be very memory intensive. You may want to have a set of instances that really meet that workload. And this also was not just a code-based change. This was really a cultural change as well, and it didn't happen overnight. It took some time. So this is something where, in order to do this, they decomposed their software teams into smaller teams. We call them two-pizza teams. And then those teams ended up owning a service. And they basically were able to deploy, and all they had to worry about was essentially what their service delivered. And they didn't have to worry about any dependencies. So as services devolve into these microservices, containers are actually a very natural fit for this. And at the mini conference down at the Mirage on Thursday, there's actually one of the sessions that you might want to look into is running microservices on Amazon ECS. And then I'll have a deeper dive into when you decide that microservices is the architecture pattern that you want to go down, how to integrate that with ECS. So containers basically make it very simple to model, and the application and all of its dependencies are packaged into a simple image using a Docker file. And containers can support any application in any language. And this image is a versioned artifact that you can then store in source control. And it really makes applications very easy to test and deploy because they are basically just building from a single artifact. And really, containers simplify your deployment. So stateless servers really allow for a natural deployment and allow you to reduce dependency conflicts that may exist in your environment. So let's talk about scheduling containers. Now that we know why we want to have them and what they are, let's talk about scheduling them. I don't know if anyone's schedule actually looks like this. If it does, I'm very jealous of you. But so scheduling a single resource is obviously pretty easy. I'm sure, how many people have actually just run a single container on their laptop? It's quite simple. But running a cluster is actually very challenging. So if you're going to run a cluster, you're going to need to know things such as, what do I do if a container dies? Do I reschedule it? What do I do if I want to put resources behind an elastic load balancer or any other kind of load balancer? How do I roll out new versions of my software? And am I going to have to go and buy another piece of software to manage my cluster or manage another piece of software? So these are some of the questions and challenges that some of our customers who are running Docker on AWS already had for us, and this is what led us to build ECS. So quite simply, Amazon EC2 Container Service is a highly scalable and high-performance container management service. And you can use Amazon ECS to schedule the placement of your containers across a cluster. And you can also integrate your own scheduler or third-party scheduler to meet particular business needs specific requirements. So let's do an overview of what the components are of ECS, okay? So first, we start with a resource manager. And the resource manager is responsible for keeping track of resources such as memory, CPU, and storage that are available on the cluster at any given time. So you can see here we have resources of EC2 instances, and they are all running Docker, and they are spread across 2 availability zones. So the scheduler is responsible for scheduling containers and tasks for execution. So the scheduler contains algorithms for assigning tasks to nodes on the cluster based on resources that happen to be available. So in order to properly schedule, you'll have to know things such as what are the constraints that I have, such as memory and CPU, and how do I find resources in my cluster to meet those constraints. Then simply I request a resource and then confirm that the resource is available and that my container is scheduled. And the scheduler is also responsible for the task execution lifecycle. So it knows if a task is alive or if it's dead, and if it's dead, does it need to get rescheduled? So ECS's solution for cluster management starts with this cluster management engine. And what this cluster management engine does is it has a pool, it looks at this set of resources as simply a pool of CPU, memory, and networking resources that it has available. And really the instances themselves are really just EC2 instances that you can go and SSH into that you own, and they are just checked into your cluster. So you can have them run the operating system that you want. You can have them configured exactly how you want. And this is dynamically scalable. So you can go and basically add instances to your cluster. You can have a 1 instance cluster. You can have as much as you can have a 1,000 instance cluster if you'd like. And you can also segment your cluster for your needs, such as dev, test, etc. And so installed on each instance is the ECS agent, okay? And the ECS agent is what allows the instances themselves to communicate with the cluster management engine. And it processes ECS commands and turns them into Docker commands. And so this instructs the EC2 instances to start and stop containers, and then monitors the used and available resources that it has across the cluster. The ECS agent is actually published on GitHub and is open source. So, we look forward to any comments or pull requests that you have for the agent. And so to coordinate the cluster, we actually need to have a single source of truth for all of the instances in the cluster, and what tasks happen to be running on the instances, and the containers that make up the tasks. So at the heart of ECS is a key value store that stores all of the state information for the cluster. So in order to be really robust and scalable, the key value store has to be distributed for durability and availability. That being said, because it is distributed, keeping data consistent is actually a pretty big challenge, right? So for example, if two developers go and request all of the remaining memory resources from an EC2, from a certain EC2 instance for their container, only one container can actually be scheduled, and the other one is going to be notified that their request couldn't get completed. So as such, a form of concurrency control had to be put into place in order to make sure that multiple state changes don't conflict. And so let's talk about exactly how we achieve this concurrency control under the hood. So ECS is built using one of Amazon's core distributed systems primitives. It's called a Paxos-based transactional journal-based data store. This is a little bit of a mouthful, but essentially what this data store does is that it keeps all of the changes, it keeps a record of all of the changes made to a data entry. So essentially, any write to the data store is committed as a transaction in the journal with a specific order-based ID. And then the current value of the data store is the sum of all of the transactions made as recorded by that journal. And if you do a read from the key value store, essentially you're just getting a snapshot in time of the journal. So in order for a write to succeed, the write that gets proposed has to be the latest transaction since the last read. So if a user made a read and subsequently several writes occurred, then they tried to write based on that last ID that they had, this write isn't going to succeed. Okay? And so this primitive really allows ECS to store its cluster data with optimistic concurrency. So at no point during any reads or write to the key value store is the data ever pessimistically locked. And this really allows ECS to be high availability, high throughput, and very low latency with regards to response time. Another thing that's really unique about ECS is the API layer. So we have decoupled the container scheduling from the cluster management. And so Amazon ECS Cluster Manager is exposed through a set of API actions, which allows you to really access any of the cluster state information that is stored in that key value store. So you can basically use the API to tie into other schedulers if you'd like, or also connect your CI/CD system if you want to do a deployment workflow with containers. And so the API allows you to connect different schedulers, as I mentioned, and it also provides logic around how to stop and start containers. And ECS actually is designed to share the state of the cluster so that you can use any variety of scheduling tools that you might need. So some people use bin packing as an algorithm for putting containers on an instance so that they have as many containers on one instance before they start going to another. Some prefer like more of a spread. If you need a highly available application, you may want to do a spread algorithm. Those are some examples of the different kinds of scheduling you can do with a third-party scheduler. So let's talk about some of the benefits of using ECS to manage your containers. So again, there's really nothing to run. This is a managed service, so you don't have to worry about the underlying EC2 infrastructure and keeping that patched. And also, it is a it has complete state management, and it manages all of your cluster state and all of your containers, and it has built-in control and monitoring. And you can really scale from tens of containers to thousands of containers with ECS. So earlier this year, we actually ran a load test And over a 3-day period, we scaled a cluster from about 200 instances to over 1,000, as represented by the purple line, if you can see in this graph here. And the green line shows the 99 percentile latency response, and the red line is the 50 percentile latency response. And as you can see, that even as the cluster scaled up, that ECS, the response time for ECS stayed pretty steady throughout, which kind of hopefully shows you that ECS is stable and will scale your cluster and have the same response time essentially, no matter the size that you're working with. So ECS actually has 2 schedulers that are built in. One is a scheduler for long-running applications and services, and then the other is a scheduler that is for batch jobs, so shorter-lived processes. And because ECS provides you with the power of APIs, it really allows you to integrate those other custom schedulers as well as open source schedulers as you may choose. And all of these really allow you to have a very flexible methods to do scheduling on ECS. More importantly, though, Amazon ECS is actually built to work with the AWS services that you're used to using. So you can set up your cluster inside of a VPC with security groups to control network access as you need. And you can store persistent information with EBS volumes that you might need to have in your cluster. And of course, you can route traffic to your containers using an elastic load balancer, or if you choose one of our new application load balancers. And of course, there is CloudTrail integration with ECS, so you can see any of the changes to your cluster all logged in CloudTrail. There's also native support for CloudWatch, so that you can get alarmed on certain states of your cluster, and you can actually respond to that as well. So again, the APIs are comprehensive, and they really allow you to make ECS extensible for your needs. And again, I would recommend that you look at the Container Mini Conference. There's a session actually with Netflix talking about how they're using ECS in their environment with a lot of customization. And so that would be, if you want to dive in further as far as how ECS can really be extensible to your environment, something to check out. And then also, we have an ECS CLI to allow you to work with your ECS cluster. And this is open source, actually, as well on GitHub. And the ECS CLI, it supports Docker Compose. So you can run Docker Compose on ECS without writing a task definition. And it's really easy to use. So as you can see here in the orange, this is the sum total of what makes up ECS. And it really allows you to reduce the amount of code that you need to write in order to go from your idea into reality and implementation when building these distributed systems. So much of the undifferentiated heavy lifting and housekeeping is really abstracted behind this set of APIs. So let's talk a little bit about services. So, how do you get your applications in containers distributed across your cluster? So you can model your application using a task definition. And everything that's in a task definition runs on the same instance. And really, the file defines the containers that you want to run together. So a task definition lets you specify Docker concepts such as links to establish network channels behind the containers and run volumes behind the containers as you might need. And the task definitions are tracked by name and revision, just like your source code, and they are versioned artifacts that you can roll back to if you need to. So in order to create a task definition, here's just a quick shot of the console and what it looks like. You specify the Docker image for use with your container. And you can specify here resources such as CPU and memory and ports and volumes for each container. And you can specify what command to run when the container starts up. There's also, maybe you can see this, an essential flag, which you're going to want to check for at least one of the containers, because that way, if something happens where the task dies, it will know that your container needs to get restarted. So underneath, the task definition is basically all JSON. So once your task definition is created, scheduling a task definition onto an instance with available resources goes and creates a task, which is a running instantiation of your task definition. So just to get the terminology down. So, there are a few ways that you can go and get it onto the instance. You can run the task, you can start the task, or you can create a service, which we'll talk about in a minute, that will handle distributing it across your cluster. So, as we mentioned, a task is essentially a unit of work and a grouping of related containers. And you can have a task that just has one container, or you can have up to 10 that really work together on a single machine. So, for example, you could start with maybe engine X in front of Rails with perhaps a Redis cluster behind it, and that would all go into one task definition. And you can really have as many, tasks on an instance that will fit based on the scheduling algorithm that you have. So ECS has a scheduler that is good for long-running applications called the Service Scheduler. And basically, you reference a task definition and the number of tasks that you want to run, and that you can optionally go and place behind an ELB if you'd like. So then the scheduler will go and launch the number of tasks that you request. So you can also configure things such as auto-scaling for your cluster if you'd like. And the scheduler will essentially maintain the number of tasks that you want to run and have it automatically load balance across your availability zones. The cluster scheduler, this long-running service scheduler, is AZ aware. So that way it will balance things across your infrastructure. And really scaling up and down is fairly simple. Essentially, you just tell the scheduler how many tasks that you need, and then the scheduler goes and takes care of launching those tasks. And it will terminate tasks also if you choose to scale down. So if you look at this architecture diagram, you can kind of see how the concepts that you know and love with auto-scaling, with instances, they're getting applied to containers, right? So you can essentially use ECS to respond to CloudWatch metrics, to scale your service up as you need. And you can have it also, even if you're doing batch jobs, maybe you're not doing a service, and you just want it to respond and scale based on perhaps queue depth or something like that in an SQS queue. And you just need to launch more containers to do that. So the integration with CloudWatch is making running containers even easier, much like you're used to already with managing applications with EC2 and auto-scaling. And again, when you update a service, you basically deploy the new version, and the scheduler will go and launch tasks with that new version, draining out the old connections. So essentially, when the old containers are moved off and then the new containers are launched, the old ones basically drain off the ELB, and you're left with the new version of your application. We also have a few concepts such as minimum healthy percent and maximum percent, which really allows you to determine if I'm going to run a cluster, what is the maximum number of containers I'm going to have. This is much akin to, am I going to do a blue-green deployment, or am I going to do a rolling deployment across my cluster? So if you have an example here, if you have minimum healthy percentage of 50 and then a maximum of 100, this is akin to doing a rolling deployment, where basically you take you apply half the changes to your cluster and then the other half. You can also do this without reducing capacity. And so here, in this case, you can set minimum of 100, maximum of 200, kind of akin to doing a blue-green deployment with ECS. Okay, so let me just switch here. I'm going to just show you an example of running a few commands here with ECS. Okay, so earlier today, as soon as I get my mouse going here, I set up a cluster. There we go. Okay, so can you all see that? Sorry, my computer's acting a little bit strange here. So earlier today, I set up a cluster. Basically, this was very, very simple to set up. If you download the ECS CLI and you configure it to connect to your to your own AWS account, it's a very simple command here. So essentially, it's just ECS CLI up, and then you just give it your key pair and say, how many instances do I want to set up in my cluster, and what kind of instance type do I have? So I picked a T2 mediums to set up my cluster, and then if I go in here, I can see that right now I have 2 instances checked into my cluster, and they are both active. But what I'm going to do actually is put these behind an application load balancer to start, because I think that'll be a more realistic view of exactly what kind of service that we want to have with an ALB. Okay, actually I did this earlier. So you can see here that in my my application load balancer, I have 2 instances inside of it. So what I'm going to do is I'm going to start with the ECS CLI, and I'm going to take a Docker Compose file that I've already created. Okay, so this is a really, really simple compose file, and all it basically says is look for the latest, which I've tagged latest image in my ECR repository. So is everyone familiar with ECR? If not, ECR is the EC2 Container Service Repository. Much like Docker Hub, it's essentially a private repo for your images. So this is a very simple PHP file that I've put into my ECR repository. And the first thing I'm going to do is I'm just going to start this service. And so the container, the ECS cluster is responding, and it's saying, okay, I'm going to start your container. And if I go into the EC2 Container Service homepage, I can see now I have a running task, and I have a repo here that I've set up in advance that has the latest version of this, which I built this morning. So now that I have that service up, I'm actually going to scale it to be, 2 container instances. My paste is not working right. I'm not connected? There it is. Haha, thank you. I needed to get rid of that other one that was dead. So this is better. Yeah. So, okay, now we have this service where we basically are running we have a pending task. If I give this one more second, it'll become a running task. Okay, so going in here, if I go to my EC2 instance, I should actually just go to the load balancer. Okay. Okay, so again, this is really just a very simple PHP application. Actually, this is also available on GitHub if you want to step through this to see what setting up the very simple container PHP app looks like. Okay, that being said, so great. We showed how we can run the container, we can scale the container. Next, actually, let's try and change this to be a service instead of simply tasks that are running. So I'm just going to take that one down, and I'm going to change this into a service. Okay, so now this is creating this as a service. We should see it reflected in the console. Okay, it's a service with a single running task. I'm actually going to scale that up to be at least 2 tasks, so it moves nicely across my instances that are load balanced. So this task is now pending. Okay, so the ECS service has reached a stable state. It set the cluster up with a service that has 2 tasks. And then basically, if you're going to go and make changes to your application, it's actually fairly easy. So what I'm going to do here is I have this PHP application. I'm just going to cd into it. If I just change this PHP file, I mean, really, it's just HTML, but you get the idea. And then essentially you can just basically run a Docker build command on this. I'm going to run it with no cache. It's kind of like doing a make clean if you're used to building things like in C or whatnot, just to kind of get any caching out of it. Because when you're just making a small change, it might not pick that change up. So once Docker build completes, it's really simple to then just go and tag this image and then push it into your repository and then deploy it across your cluster. Okay, there's about 10 steps here, so it's almost finished. So if I do a listing of my Docker images, I see here this latest one was created just 3 seconds ago. And I'm going to go and log in to my AWS ECR, my EC2 repository. So I'm logged into that. And I'm going to go and tag this as the latest version. Okay. My repo, it has a little bit of a strange name. It's basically my account ID, .dkr, and then the region that it's in. So I've tagged it as the latest, and now I'm going to go and push it into my repo. And then if we go into the repository, take a minute. And we can see here, this is the latest version, much later than the ones that I did earlier this morning, 1042. There you go. So now that I have that latest version in my repo, I basically want to go and update the service. So probably the easiest way to do that, and which we'll do just in the confines of this quick live demo, is just I'm going to scale the service to 0 and then scale it back up to 2. So there are other ways to do this, and I recommend going to some of the other sessions, and then you can see how when you're going to be doing this at scale. Certainly, you don't want to be manually updating your service. That being said, for this purpose, it's quickest and easiest way to do that. So as it's updating, so new version of the application deployed. And again, you can do this with 0 downtime, and we have some sessions that'll go through and talk about how to do that. That being said, about 15 minutes left. If you have any questions, we can start going into that, but before, let me just go back here. Essentially, remember to fill out your evaluation form and take a look also at some of these related sessions that are available at the mini-conf on December 1st.